move through our next portal. All right. Anyway, and again, welcome to Netpedia classes, Cisco CCNA 200-301, Chapter 1, Introductions to Networking Basics and Devices, Day 05. And we learned about almost a little bit OSA layer and what is the difference between hub, router, and switches yesterday. A bit of the understanding, yes, we know. And a little bit of the layer, how the layer 1 and 2 and 3 segregate with each other and how we differentiate between the layer operational side and how it works. Let's watch our little video that we made for the Cisco Catalyst. This is a Catalyst switch, which is a very expensive one, and it's a very great to work on that. And nowadays, I believe Cisco is preferring everybody, and it's a recommended for the industry practice to use Cisco Catalyst switches. Those are layer 3 and layer 2, both they work on. Let's watch a video and look like how it looks like. And this is our video. This is Cisco Catalyst 9300 series Cisco switches. This is actually being used as a WAN gateway nowadays too. Like you can replace your router with these kind of switches. But I'm just showing it. In the future we will surely see it how it really works. But really we have to follow about with the Cisco and router switches, layer 2, layer 3, everything. So this is just a new type of switch that came up. So it just somebody showed me up, and I was really impressed with how they made this thing. So I really wanted to show you. So let's start it here. And this is how it looked like. This is a model of switch which is called 9300. Play the video more. And so these things which it says from 1, 2, 3. This is 48 interface. 48 ports. In general, we say that 48 ports. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can plug my. Yes, sorry. I'm audible again? I'm hoping yes. I'm audible? Yes, no, in the chat? Okay, thank you. Okay, so we call these guys interface. What is it primarily meant for? Interface is any kind of gateway or door. Let's say you have 5, 10 devices you want to connect to each other. We call it interface. Interface in general terms, if you go for English meaning, just as a dictionary. So interface means any kind of platform or a door or a gateway, which will allow you to go to a next portal or go to it's kind of just a communication door, just a communication door. Not really a different meaning, but just as a Cisco or any kind of networking devices and uses, they call it interface. You can have application interface too, or a hardware interface too. So this is we call like all these are interface, and these are, if you count it from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you may have a 1, 2, 3, and 4. So you have 4 slots. And you have 12 on each, so 12 into 4 is equal to 48 ports you have available in this switch. So it means you can connect up to 48 devices, 48 either laptops or 48 other computers, 48 printers, any kind of 48. Or you can even put one more switch together too. So and then it will keep growing. right? Okay. What were the other instructions here? That it's a high density 10 gig port. The high density 10 gig port. 10 gig means you can have 10 GB connection. Please mute yourself if somebody's trying to. Please mute yourself. And it's multi-gigabit 90-watt power. Let's say you have any wireless device here connected, or it could be a camera connected. What's that? AJ, please mute yourself. Thank you. Is any camera access point? So if they require power up to 90 watt, you can get power from here directly. You don't need to put any plug or any power source. Any power source. You can directly give power from here, from these ports. You can run up to 48 cameras right from here, right from these ports. So that's what we call multi-gigabit 90 watt. It means 90 watt you can give the power U plus. It was used to be PoE. Then the PoE plus came. Now is new one is it UPoE plus, ultra power of Ethernet plus. It means you're getting the internet as well on this cable as well as power as well. So it can use for both things. So it would be understandable. That's fine. Like we can go ahead with the next slide. Yes, no? Okay, I will go yes. So let's see more. And now, if we go a little back here, so in the last time, in some of the sliders we have, in the last time when we, I think day 3 classes, I showed you there is a new type of console cable. So this is a management console cable. Console cable. This is a maybe type micro B, like Android cable. The Android cable used to be type micro B, and now it's type C, right? Now it's this kind of type C, but it's not being used right now for as a management console, but this being used for storage, for sure, external storage, and even this one for extra storage. But this one you can use for console into putty. Console, putty, and any kind of management console you can directly run from this cable. You want to configure this switch, you just plug that cable, put it in your computer, turn on putty, and use the serial console with the device from the device manager, COM number 1, 2, 3, 4. Whatever the device you use, it will just come up right over here, and it will show you. So go for next. This is USB A storage. Like if you need, let's say you want to download a firmware. So let's say you want to download a firmware. You don't need to do anything. You just plug or upload a firmware, download a firmware. You just need to put a USB storage, or you just any kind of device like USB, those sticks, USB sticks, 8 GB, 10 GB, and all, right? You just stick it here, and when you go to console, if you put command dir, it will show you, okay, this USB is connected. So you can upload config here, download config, even the download firmware. You can upgrade this whole operating system of this switch, and you can try a lot of stuff. You can do it. It's a really great stuff. So they want to make your life simple, so that's why they brought this stuff. Let's go for next. There's a USB-C port. It works for same thing. It does not do anything else. It's just the same stuff that USB-A does. Now let's go at the back of the switch. Okay. So there is something called module. Let me show you that module, how it look like. If I have it here. Fine. the day cable here. And yeah, so this is a module kind of stuff. You will insert this module, right? You will insert this module here. That's an open space here. Right now, you're seeing it right now is, it's a covered, but you can open this and you put this kind of module inside. Here, it will go inside and it will give you 100 GB. It will give you 100 GB port. So you can do the 100 GB actually. 100 G. And why you need 100 G? 1G module uplink, why you need 100 G here? So let's say you want to put one more switches here up top somewhere. And you can have a switch to switch communication. So those switches will communicate over 100 G because you want more robust connection between switches. Those we call like trunk ports. Like we could be making a trunk between the switches. So you would need 100 GB. That's how it works. So you put like that. Understandable? Pretty easy? No confusion? Yes, no?
Sir, can you please इसको आप वापस से बता सकते हो?
Which one? Okay, so this, let's say, you have one more switch here, right? Have one more switch here, and same switch like this, two switches, and you want to communicate two switches together. So what you could do, you need a high density between. Let's say if you put the switch here and switch here, so this is only 10 GB port, and you have a 10 GB port here. So you only can allow 10 GB traffic from here, right? So let's say you have 48 devices here, 48 ports here, 48 devices, 47 devices you already occupied, and you have 47 devices here. All these ports are filled. And every device need how much? 1 GB internet, right? Every device need 1 GB internet, right? So you have 94 GB already internet, right? 94 GB you need. So can you travel from 94 GB into this 10 GB connection per second? Your demand is 94 GB. Your demand is 94 GB, right? But you only can supply 10 GB here. So what will happen? There will be a network drop. There will be what? Network drop, because you cannot communicate over a channel. Let's say just a single pipe, right? You have a water line pipe here. This is a water line pipe, right? And there is 100 people standing here. Everybody need 10 liter of water every day, but this pipe only can carry what? How much? Only can carry 50 liter of water. So what will happen? Only 50 liter of water can come. So other people has to stay in the queue until the water can come, right? Same thing will happen here. So other computer has to stay in the queue to get the internet. Did you get my point here? Any problem now to understand why we need 100 GB this connection?
No, sir.
Like what? You didn't understand?
No, sir, I understand.
Okay. All right. Thank you. Okay, let's go for next slide. It might go shoot back. It go the back of the switch. This is how switch look like. Yes. And this is SSD blank. So what we could do. So why we need external storage? So when any kind of machine runs, it need more space. Like let's say your computer, right now the switch works the same as computer, nothing difference. You need more space. Why you need more space? Because you want to save your log files, right? Log files. You want to save a lot of application software files, right? For longer time, for 3 years or 2 years. So you need extra space here. Or you may want to run multiple operating systems. So you must have extra space. So that's why they give you external storage space here. Okay, you can put more extra storage like a small RAM. Remember like those small, hard drives used to came like a very small ones, because used to microchip and all, right? It used to be the old phones, like Android phones, we used to insert that microchips. Right, microchip have like 180, 20 GB, 128 GB RAM, 8 GB we used to call it. So you can put it inside here. And this is same. This is for console cable, right? And this is for Ethernet cable. If you want to manage your internet through the Ethernet cable, switch from the Ethernet cable, so you can plug it here rather than on the top first one. It does the same thing. These all three ports work same. The first port that I showed you here and these three ports, they have the same purpose because they want to give you more access to easy access for configuration switch. So that's why they gave you. And this is for ground cable. Ground cable. Let's say you have a lot of electronic wires around this switch. So you must give a ground. You must get a ground from that switch. Must. This is a good practice actually. So let's say in any electrostat came, EMF or electromagnetic interface came, so maybe your switch will have some problem due to that. So that's why you need this. That's ground cable. And go to next slides. Clear? Everything? That's RJ45 console. And dedicated stack wise. Let me show you what is stack wise. So must be this is a stack cables. This is what? A stack cable. This could be under Cisco 9300 like stack cable. Looks like this, same look like this. There's nothing difference. This could be 50 centimeter, depends on your need. So this is a stack cable. Why you need stack cable? Like to this. To do this. What is this? This is called a stack. So mostly catalyst switch now. Why Cisco made the catalyst switches? To give you more robust network. So right now, if you connect your switches like this with this special stack cable, so your whole switch become one, unified. In sense, this whole switch can be managed from one, and you don't need to worry about anything. Then even one switch goes down, the second will goes up again automatically. Even you can run active, all those switches. I'll show you in next classes, but it's just an overview here. You don't confuse with that. I didn't show you much, but it's just an overview. Do not say that, okay, we're not going to learn it more, but we will learn it more in the future. And I will tell you why why you need a stack. So this is a good stack way. This is a stack. That's how the stack works. Okay, and what else we need to do? This is a stack cable. This is a modular FRU fans, like just for fans, to cool the systems, cool inside, motherboard, so it doesn't overheat your CPU. Just like a computer, you have a fans, the same stuff. And then you have these power supplies, right? You mostly have double power supplies nowadays. The reason behind it, let's say this got faulty, something like fault here, right? So you must have one backup here, backup power supply. It will automatically do not let the power, even the zero downtime. If something happened to this power supply, it will automatically run from this power supply right away. And this is a good feature from every network devices have nowadays, dual power supply, almost everybody. So that's how it works. Anything problem here? Like any confusion that we need to clear so far? Yes, no? Okay, I'll move forward. And this is stack over ports, stack power ports. So these are the stack power ports that actually does the same stuff for stacking this power. Let's say you want to have another switch that works from, so you want to give a power from this switch to another switch, so you can use this port. So this power supply will do that. So now you don't need to put a power for another switch. You can give a power from that switch. And that's our power supplies. And that's all. That's a nice switch that looks very great. It's a pretty expensive for sure, but it's really most of the company now they're using. Like I've been worked on these switches so far from 3 years, and that's a great switch. 9200, 9300, 9500. Oh, that's a really great switches, and I'm using this for a long time, to be honest. Okay, and we just go for our introductions. So what we learned so far? Yes, go ahead.
But this switch doesn't support PoE++, right?
What it doesn't support?
PoE++.
No, it does support. It's the ultra power UPoE plus. So when you have a UPoE plus, so it supports all the backends. So backend always a compatibility. Let's say you have a layer 1 compatibility, layer 2, layer 3. So same as here. So it's a UPoE plus. It means it compatible to the PoE plus, PPoE plus, and everything. So it does compatible everything. So you can. It's a 90 watt. So 90 watt means like you can run a TV from that switch. So mostly TV nowadays are that you're getting nowadays. How much the LCD monitor TV get much too much, get the current or the power, how much power you need, or how much wattage you need, 60 to 110 wattage, right? To run a TV, a small TV, right? So it is giving you 90 watt. So it means you can run a full TV on that port. So it means it's way higher than the PPoE plus, way higher. And these switches are really great. That's why they introduce it, because they know this switch can be run for video graphic and all stuff that too. So before, in 2015 and 14, if you see that when the networking came with more new devices, so that, in the earlier when I used to work like in 2010 and 2008, for camera, there used to be a different kind of switches, right? And for videograph, or if you need one or more video stations and stuff like that, so you need to buy a special kind of switches. So, and for data and for voice, there used to be a different kind of switches. But now Cisco and every network vendor do not want to do that. They want to put one switch and you can run on everything. You can run everything. You can run cameras, you can run TV, you can run video station, you can data, you can do voice over IP on one switch. So that's why they are doing nowadays. You don't have to spend extra money, and it's a lot of extra wastage of money as well, and extra wastage of products as well. So that's why they're keeping one simple card with one simple power supply, and they are giving you all kind of services. So that's why the Cisco switches Catalyst switches are especially doing this kind of thing. Okay, understand? Any problem? Any confusion that need to be clear now?
No, it's all clear.
Maybe on the internet, somebody you see, okay, doesn't do the PPoE and all, but it's not like that. If you really check with the Cisco device, segmentation, you will see everything. So there will be a a documentation with a segmentation. Okay, what you can use, what kind of compatibility it has. So that's all the one. So I showed you this. So this switch has everything: PoE over switch, and it's stackable, WAN managed, smart, enterprise. So this switch that I showed you, it does it does everything. It's explaining everything. What is enterprise switch? So this switch actually covers everything. What is cloud managed switch, data center switch? And this is the switch that this switch actually show you. Okay, PoE is that. It has a PoE, it has a stackable, it has a WAN managed, it has smart, enterprise, industrial, data center. So this actual special switch C9300 cover all these points for you. That's why I explain you that by the video. And the campus switch, you can use this for campus switch as well, for large educational or corporate campus. So you can use it for that as well. So now today's why I actually wanted to do this meeting after those switches interface and everything. The reason behind it was all cable types. Like what are the cable, and what I showed you what is the interface, right? Everybody knows what is the interface? Yes, no? Yes, no?
So connected door?
No. You see that, right? What does the interface look like? You know the picture, right? In your mind?
Yes, sir.
Okay. That's all I want to know. So interface, so if you have an interface, then you want to connect a cable as well, right? You want to connect the cable as well for the interface, right? So interface must need a cable. So if any switch want to communicate with anything, you need to have one cable as well, right? You need to have a cable as well.
I couldn't hear the question. Could you please repeat it again?
What does the interface look like, right? How our interface
Yeah.
look like, right?
Yeah.
Okay, that's what it was. Okay. you know what, like interface is kind of so many wires here, 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 and that's a small box look like inside, right?
Mhm.
Yeah, so that's I wanted to ask. Okay. Okay, so all cables, so right now there is a standard now. So when you have an interface, you have a standard. So that is we call Ethernet standard. What do we call it? Ethernet standard. So you would see, despite of what type of, it could be fiber cable, could be coax cable, could be any kind of cable, but you always use a protocol called Ethernet standard. What do we call it? Ethernet standard. Doesn't matter what kind of cable you're using. Are you using fiber cable, Ethernet cable, like cable with the Ethernet that is called copper cable, coax cable, all are Ethernet. All frames are what? Ethernet. Ethernet. That's how it being that how they standardize these things. So what is Ethernet? Ethernet technology provides rules that allow network connected device to talk to one another without talking over each other. In a verbal conversation, when two people speak at the same time, each may have difficulty understanding what the other is saying. This is simplified, says 10 people are talking at once. Imagine 100 or 100 ones. So what that means, let's say, let's say two persons, like say there is a, right now we're doing a Zoom meeting, right? We're doing a Zoom meeting here. So we're doing a Zoom meeting, right? Let's say I'm tutoring right here. I'm speaking something. I'm saying something. Okay, and right away there's, let's say, Aditya, Chaitanya, everybody starts speaking. Everybody starts speaking. Okay, what will happen? Would anybody will understand anything? Yes, no. Would anybody will understand anything if everybody start will talk? Nobody will listen. Yes, no. Like in the chat. If we all talk together, keep talking, nobody listens what other person saying. So what will happen? Would be able to understand a single word? Yes, no. Like I'm asking everybody. Okay, Chaitanya says
Please,
no.
can you repeat the question?
Sorry, can you what?
So please, can you repeat the question?
Okay, let's say we are on the Zoom meeting. Not Zoom meeting. Let's say we are standing in the public right now. We are standing what in the public right now. Let's say we are standing in a hall here, right? In a hall, right? And everybody just speaking. Everybody speaking, speak. Everybody just loud, saying hello, hi, hi, hi. Everybody saying, like not just hello, hi, like they're just shouting, they're yelling. Would be able to understand any single word? If everybody.
Hello, sir.
Hello,
Hello, sir.
hello. Okay, go ahead. Want to say something, Aditya?
No, sir.
Okay, let's say no, we won't be able to understand. That's great. Okay, somebody gave a great answer. So we have something called new stuff. If somebody gave a good answer, what we do, we call it congratulations to that person. And what we do, we just run a small sound for him. And that we call good answer. Very good answer. Yes, no. No, we won't be able to understand. Why we won't be able to understand? Because we would not know where the sound is coming from, right? I'm right now saying hello, 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 and everybody saying hello, 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 hello. We won't understand a single word. We won't understand a single word. Nobody will, because you're just speaking, nobody is listening. So that's why the Ethernet standard came, right? So a switch, when a switch here connected, these are interfaces, right? These are interfaces, right? When interface connected to a computer, there is one more computer, there is one more computer, there is one more computer, there is so many computer here, right? And what happened? This is a cable here. So this is a cable here. This is a cable here. This is a cable. This is a cable here. And these cables are what? Ethernet cables. Ethernet cables. So what happened? Let's say this guy sends the traffic, right? Sends the traffic here. and it send a traffic to here, right? Something like that. Or you can just change a little bit of color. Okay, let's say I send a traffic here, I send a traffic here, it's coming here, I send a traffic and it's being here, I send a traffic, it's being here. So what will happen? It's just sending each other. Like it doesn't switch, nobody will know, what packets are coming, or like it could be a collision here. On the same wire, you send something, and maybe this guy is sending to you as well. So what will happen? There will be a what? Collision. What will happen? Collision. A collision will happen. What will happen? Collision. Like you will have a, how two cars, let's say on the same road, there is a one way, and there is another way, right? And there is a car coming on this side as well, going on to this side, and same cars are coming from this side as well at the same time. What will happen? There will be accident, right? Yes, no? Sorry, I couldn't understand. Anybody said something? Sorry, buddy, you're not audible at all. I can't hear you anything. Maybe your internet is pretty low. So, yeah, you can say something later. Like you can put in the chat. You can say in the chat. So you have, let's say you have a car here, and right, that's a pretty simple, right? That's pretty simple. Like you have this roadway pathway, and there is a stop sign here, there's a stop sign here, but it keeps, all the cars are going on this path, and same cars are coming from this path. What will happen? There will be accident for sure. Same with the cables. If a switch is here, and there is a computer is connected, and if he's sending a traffic to this wire, and same wire we are receiving a traffic, what will happen? Traffic will collide to each other, right? Like any kind of data will collide on the wall, on the wire. Data collide on wire, right? And what will happen? There will be a disruption of data, right? Disruption of data. Yes? No? Yes? No? Put in the chat. Clear? Okay. Okay, says yes. Anybody else? Buddy, can you put, everybody can put in the chat. Yes, no, please. Everybody? Justin is there. What else? Chaitanya, you? Okay. Aditya, you? AJ, agent. I don't know who's that agent. I don't know what the name. Okay. All right. So there is a problem, right? So you have that's why what we did, we put an Ethernet standard here. So Ethernet standard there, what does that mean? So you have a cable, a special type of cable that we created, and special type of interface we created in the switch. When this computer is sending here data, so it will stop. It will just listen. It will send to other person. Then it will check if this cable is empty or not. Okay, there is no data, then it will send back data to here, so it can receive. That's why what we did, we made this Ethernet standard. That's why we made Ethernet standard. That's why the Ethernet standard came into the market and came into the network real world, because you need to have this. So that's why if 10 people are talking at once, imagine 100 at once, 1,000 at once. The same is true for data network. If two or more connected devices on a shared network attempt to transmit data packet at the same time, a packet collision occurs. The pulses of electricity of photons that make up a packet overlap when sent at the same time over a shared copper or optical cable. This jumble the sequence on pulses on and off. Voids that are sent to indicate that bits and bytes of 1 and 0 that make up a packet. I'll explain the next class what is 0 and 1s, but we will surely see that. Ethernet 1 was designed to solve that problem of packet collision. It provides network devices with a set of rules that essentially make sure no one else is talking before you talk. That is most important rule of Ethernet. Make sure no one, okay. Okay, so no one else is talking before you talk. If you hear someone talking while you're talking, stop, listen, and wait for the end before you talk. Ethernet is commonly associated with the connected devices in a wired LAN or WAN. Using wired Ethernet cable, devices are connected to Ethernet switch. Ethernet has the ability to use both wired and fiber cables, delivering not only data, but also power. Not now up to 90 watt with UPOE plus. More formally, Ethernet is a common name for IEEE 8203, which is a standard name for IEEE, like, international engineering, engineering expertise industry. So they are the standard. They are the who make standards, and we follow all the electronic standard on IEEE, right? IEEE, and 82.3 is a standard name which we follows. And that standard based on the carrier sense multiple access, like this is a like CSMA. CSMA.
Excuse me, if you are sharing the screen, I cannot see.
Oh, I'm sorry. I've been sharing it. Okay, it's now I'm sharing.
Yes, it is. And forgive me, can I have the topic of today?
Topic of today. So topic of today.
Different than yesterday.
Yesterday was difference between router and switches. Today's topic about Ethernet.
Okay.
Ethernet, yes. So right now we are not going through the topics. The reason behind it, we did not start a really good, practical practice yet. So this is just an overview of how the networking works. So I'm explaining you way more further about how networking works. So when a real, the CCNA will start, then we will go more further. Right now, just an overview. So yeah, this is very important that I'm explaining, but still it's an overview. We still not even start the full course, right? Okay, let's see that. Ethernet is commonly associated with connected devices, a wired LAN or WAN used in an Ethernet wired cable. Devices are connected to Ethernet switch. Ethernet has the ability to wire and fiber cables, delivering not only data, but also power. Now up to 90 watt with UPOE plus. Right, more formally, Ethernet is a common name for IEEE 82.3, which is IEEE, and IEEE is a industry expertise, or let's say it's an electronic standard. This is a company, or can say organization, who take care of these standards. So you must have one company at the top. Let's for internet, you have IANA. We will surely talk about the IANA too. And same as for electronic, you have IEEE. Standard based on carrier sense, CSMA, CD, collision detection, like you can say CSMA CD protocol. CSMA CD defines when to transmit and what is to happen if a collide is detected. So as well as the endpoint addressing, transmission speeds, and media, Ethernet has solved dramatically since its first application. Today is the de facto protocol for IP-based network. So this is the best practice. Ethernet is a best practice. So you have a switch here, and switch here. There is a one computer here, one computer here. Both are sharing to talking to each other. So this CSMA somewhere here and here, CSMA and CD will decide when to transmit here and when to transmit here. So there is no collide happen between each other. There is no collide happen between each other. That's what happened CSMA. Clear? Any confusion so far? Yes, no, chat? No?
Yes, it's fine. It's fine.
Fine. Okay. Let's put one more applause for you. Okay, let's go for next now. So this is a pictogram of cables. These are the pictogram of cable. This is a pictogram of cables, right? We call it CAT cables. What we call it? CAT. CAT. as a copper end-to-end transmit cable, the copper. Then we have a fiber cable, which is fiber optic cable. It does on light, right? It works like optic lights to transmit the data. It does just a simple electronic, right? And it all under the Ethernet program. Say they are in the same. So even doesn't matter which cable you're using, even this, they're all are what? Ethernet cables. They all are what? Ethernet. They follow the same Ethernet frame, Ethernet protocol, Ethernet standard. Doesn't matter which cable you're using. You must be using the same sort of. So where we use it, this guy, you would see at home here as well, or if you're connected to via your modem, so you will see this cable, right? Even you will see this cable as well if you have a high internet. So maybe your ISP even given you 2 fiber cable that connect to your modem, right? Have you seen these cables before? Yes, no?
Yeah, of course, of course.
Okay, that's great. Okay, let's say no, sir. Okay, and single boosters. These are coax cable that used to be, now we're not using anymore. It used to be primarily like in 1990 or 1960 when there was no, there was no UTP cable or CAT cable. So we used to connect these cables for, internet, but still you're using it for satellite, some sort of satellite connectivity to your dish, right? Disconnections. You use it for ISP directly over the voice carrier. So you still use somewhere these lines. You slowly use somewhere these lines for RF connectors, for RF audio and video, but not really generally for internet purpose. You don't use it. You use either fiber or either use your CAT cables. And this is in the last class, in the first class, we saw about, okay, what is DB9 connector and what is console cable. So these are those. And these are obsolete cables, that serial cable that it used to be the serial cable used to for 2 device connected, even the computer or either the switch or special type of switches you used to connect for serial S232 cable. That was a very in the market for long time. They stayed for 2000 until 5. We used to use this cable for internet, right? But now no one uses these cable serial because it's used to be very low in the bandwidth and you can't carry too much signal. So that's why we're using for high bandwidth, and for these we are using fiber and CAT cables. Clear? Any problem? Any confusion so far? Okay.
Oh, understandable.
Okay, thank you. You just can put in the chat. You don't need to unmute. You can just put in the chat. Okay, and okay. So there are in the CAT. So if you go back to the slide. So this is a CAT cable, right? This is a CAT cable, right? And go to the next one. So these are the CAT types. These are what? CAT type 1, 2, 3. It used to come in 1990 something. It's only for voice over IP, not voice over IP, sorry. It's only for analog phones, which only calling to each. Let's say you used to have those phones in something like 2005 or 1990 when there was no IP thing was released. So you used to have phone, what do you call it? So it used to be very random rings. So that used to have CAT1 cable. Then you have to have a CAT2 cable for connecting internet. Then you used to have CAT3. You still use CAT3 somewhere for voice over IP. Still you use CAT3. You don't use CAT1, but use CAT3E as well for a 10 Mbps connection where you just need a small voice and a small camera. Like you don't need a full voice. So use CAT3. CAT4 is rarely being used, very rare. CAT5, I still see that, and some people are using CAT5. Still, some people are using CAT5, and CAT5 is kind of, let's say, CAT5 standard for 100 Mbps. Let's say you want to connect it to your computer, right? So you used to have 100 Mbps. Now everybody moving to what? CAT5e. And I think CAT5e, the standard came in 2005, 2007, right? Still, CAT5e, it can transmit up to 1 GB. right? If you have 1 GB data, want to communicate, so you can, and frequency of 200 megahertz. And then we have a Cat6. Cat6, same thing. It's Cat6 and 5e has the same. There is no more difference. It's just a little bit of interface. So a Cat6, like even you can Cat6, you can go more than 100 feet with the same signal. And Cat 5e 1 GB is only allowed when you have around something maybe 150 feet or something. Or they can go on to 300 feet. And Cat7 is rarely being used, but it's really costly for sure. And that's around, you can get a signal up to 10 GB. So today's switch I showed you, it has a 10 GB interface. So you need to have a 10 GB cable as well to get a 10 GB network. So if you put 1 GB cable onto 10 GB interface, what will happen? You will get only 1 GB internet, right? Same as that. Any problems so far to understand that? Any confusion so far? Any confusion? No? Okay, thank you. So Cat6 up to run can up to 10 GB, Cat7a up to 20 GB, Cat8 can go up to 25 GB. So that much data on the single wire you can transmit with the 200 megahertz of frequency. So that's just a basic. We will learn more about that in future, why we use, where the scenarios we use these things, right? So let's go the next. So now we have something called UTP.
I asked a question.
Sure, go ahead. Yes, please.
Regarding the cable, Cat7a is not recognized by TIA, but I was wondering why it's not recognized by TIA.
Why does not recognize by what? Can you put in a chat, please, so I can see
By
your
TIA.
Can you put in a chat, if possible? Because I'm not, you are able TIA. Check. I don't know what the TIA is as. No, that's a TIA is another standard. Okay. Okay, so what happened really? Okay, so that are actually, okay, so I got it now. Okay, so what do you mean right now? Okay, I got it. So TIA is a standard for female jacks. TIA is for female jacks, right? Female side, not the male side. So TIA is a jacks, kind of wall jacks, where you see that, mostly these kind of standards there, right? We'll talk about that more in future, but not now because we are covering the another stuff. But surely we will talk about, explain more in the further in the next classes. Okay, then there we have twisted pair cables. So every cable, what is UTP and why we twist the cable? So why we twist the cable? Anybody has any answers so far? Like if you guys ever encounter with any cable, and if you open any Ethernet cable so far or RJ45 Ethernet cable, have you ever unshielded the cable by mistakenly, even though when you was connected to something else and you broke that cable? So
I
we
do
have
it untwisted, yes.
okay. So why do we twist the cables? Why we do twist it?
Yes, because when it take a curve or when it's a tool, each twisted cable is not the same tool. some of them is more taller than the other because
Yeah,
when
more
you twist
tolerance
the
of
cable
other.
itself.
Yeah, okay. Okay, let me go ahead here. You can put in the chat too. It's much easier because you know the very disruption on your voice I can see because it's not pretty clear. So what really happened? Let's say you have an electronic interface, magnetic interface, EMI or EMF. These are the kind of same stuff. So you have a cable, right? And let's say you're running 10 cables here. You have 100 cables of bundle here, and you're running top of that maybe some electronic cables, like electrical cable that's with a 100 amp or maybe 20 amp cable, right? So there could be a disruption here of noise, could be just because of the electronic interface here that can disrupt of these cables, So what you do in that case, you twist it each other, so it will balance everything. When you twist the cable, it will balance all the electronic media interface. It will balance it. So that's why we use twisted cable, both either shielded or unshielded. Doesn't matter what kind of cable is that. You always twist it. So it's much better for much easier. Yeah, it's much easier for. Yeah, it's much easier for shield, much easier for data transmission. EMF can be balanced here. You can balance the EMF. So now twisted pair cables are both shielded and unshielded, are commonly used in networking telecommunication for data transmission. The choice between shielded and unshielded twisted pair cable depends on your specification, application requirements, and environment factor. So what type of environment you have, you will use that cable. Not for isolation. It can be used for anything. Okay. So unshielded are cost effective. UTP cables are generally more affordable, right? If it's unshielded, for sure, you don't need to put, your machine do not have to work. You have a less resources to add, less material you need to add. So it's making them a popular choice for many networking application, right? Flexibility, UTP cables are more flexible and easy to work with. You can easily terminate, right? And they're thinner and lighter in the construction. Let's say you have a pipe, you only can put 10 cables. So shielded only can go up to 7 to 8 cables, but untwisted or non-shielded can go up to 10 cables on the same pipe. So that's a good thing. And the interface tolerance environment with a low to moderate electronic interface and radio frequency interface, RFI, UTP cables can perform it. If you have a low tolerance, then yes. If it's a low EMF, yes, you can use this kind of cable. Let's say you're not running onto high voltage cables. You're not running on the high voltage cable. Yes, then you can use it. And common uses are like inside the offices mostly, right? And commonly used Internet Cat 5e, Cat 6, Cat 6a, 7, and telephone lines. Like when on the office and somewhere, let's say, under the bucket or under the hood, or under somewhere in the chairs, or or running on the ceiling where there is no voltage cables are there. You just have open space. You can run these cables. Yes, you can run these cables. I used to work with that, so I still remember when I used to run these cables. And then we have a shielded cable, very heavy cable. Like it will take, oh my god, it's very heavy cable too. Even you need a special type of scissor to cut these cables. Really special scissor you need it to cut this cable. That's a good one. And then we have EMI, RFI protection. SDP cables are designed with a metal foil braided shield around the twisted pair. So wow, that's good. So there is a two. One is just a foiled cable. Another is foil with shielded cable. So there are two cables for sure. And then which provide better protection against EMI and RFI. This makes them suitable for environment with high levels of electrical noise. Let's say you have a 100 amp wires are going around here, and you want to run your cables, internet cables as well. So you would need shielded cable. You would need shielded cable running around here. And then grounding, the shield in the SDP cable need proper grounding to be effective. Remember, I showed you one ground cable in the switch at the back. So same thing, you need to put this on a grounding of this cable as well. For where on the switch rack, there is a special cable, the grounding cable goes to a ground, and all these RFI, all these shielded cable must be grounded to that cable. Must be. And degradation due to external interface. So grounding, always important. Enhanced performance, STP cables are often used in more demanding application where signal integrity is critical, such as data center, industrial environment, and medical facility. Yeah, where you have a high data center, which is high volume of data traveling through one cable to another cable or one switch to another switch. So you must need a shielded cable for that. And higher cost, yes, shielded cable have very high cost, almost double the cost of the normal UTP unshielded cable, almost double the cost. You will see when you go for buying these cables, or when you become a contractor, you will see how expensive these cables are. I quoted for a couple of other companies. Yes, there was. Then we have these UTP shielded and unshielded pictures, right? And we have these are pictures like shielded cables and unshielded. This is unshielded, right? And this is unshielded with buffer cable. This is Cat 6A. This is Cat 5E. So this would be Cat 5E, and this should be Cat 6A with buffer inside. This is the actually make it a strong twist pair. So this is just twisted to each other, right? This is twist to each other, and this are twisting to each other, but this buffer twist all the cable together as well. Understand? Any confusion here? Let's say there are two cable, right? One cable is coming here, like 4 cables. Actually 4 cables, like you have 8 pairs inside. So this is just unshielded, twisted, just twisted. But when you have a Cat 6A, so these cables twisted to each other as well. So you have a more electronic magnetic tolerance there. More. That's what this cable Cat 6A works on this portion. You will see when you open the cable how hard it is to open. Then this is shielded. This is shielded with foil. This is most probably for power cables. Most probably for power. Even you can more power, like you can use the internet as well, but mostly where you need more power, like 90 watt and all. This is just a foil. This is just a foil. This is just a shielded over only the pairs, and this is foil over shielded, the cable I was talking about. So there is a foil as well. See, there is a buffer foil as well, and there is a shield as well. Then on the shield on the cables as well, like on these cables, there's the shield as well, and there's a buffer foil inside as well here, like on this here too. So that's why this is a very important part. So this is a very expensive cable. This is same expensive too, expensive, very expensive, kind of expensive, but this is kind of cheaper. You can use in offices. This one office too. High tolerance, high tolerance, high tolerance, high tolerance. And this is how the roll look like. When you buy a cable, you buy in the roll or in the box. There could be a box as well, but mostly nowadays they put in the roll. So it's easy. There is no crack in the cable. So they give you these kind of rolls. Any confusion so far? Anybody? Yes, no in the chat? No? Okay, let's go for next slide. And then there are the cable types. So there's a cable types. Again, it's just the same thing where you use the Cat 5E, because right now we're not using Cat 3 and all. So we're starting from Cat 5E, Cat 6A, Cat 6E, Cat 6A, Cat 7 right now in the market. So you can use for phone lines, home network, office network, but not in the data center because of the 100 megabits, 3 hours, 1 terabyte to be transferred to take, and 100 base T data transmission. RJ connector would be RJ45 8P 8C. Maximum range up to frequency range would be 0 to 100 megahertz. Frequency maximum 350. Yeah, and you can run for 320 feet. You cannot go more than 320 feet. You cannot go more than that. That's the standard. You can go, but you will not be able to detect in your connector. And it's a Cat 6, Cat 6, Cat 6 with the home network, office, and phone lines you can connect. But it's the same as Cat 5e, almost. And until 180 feet, you can have 10 GB. Until 180 feet, you can have 10 GB on the same. But after 180 feet, you will not have 10 GB on the same cable Cat 6. Cat6e has the same stuff, but you can use it on data center as well. That's a more specification, and it's 1,000, like it's a 1 GB on the anyway, but mostly it's used for 1 GB, but 10 GB again for 180 feet. If you go more than 180 feet, you will receive only 1 GB internet. Then you have a Cat6a. You don't use for phone lines, you don't use for home network, but use for office network and data center, and 10,000 megabit, like 10 GB, like everywhere most of the time, 10 GB, 10 GB, 10 GB. And then you have a Cat7, you only use for data center, and 10 GB, 10 GB exceeds base 10, 10 GB base T, and GC5 and 328 GB, you will all the time, you will receive 10 GB internet, 10 GB data. You can travel from here. Okay, let's go to next then. And then we will be winding up a little bit. Okay. Okay, sorry, this shield is up. Let me show you how our cable termination happened. Okay, let me show you how our termination happened. This is a small video that would explain. Just a sec. Should be back. Now you can see the screen again. Yes, no? Okay, so that's a small video that will tell you how a cable connect to each other, like how we terminate a cable, especially the female jack. So that's a female side jack. That's a female jack, actually. Female jack, not the male one. But in the next class, we will read about, you will see that male jack as well. Okay, let's see that. So here's a male jack. So what you need a stripper here, which will strip the cable. So when you do it here, yeah, it will strip the cable out. Am I audible? Yes?
Yes.
Okay. So now that's how you strip a cable using a scissor. You can use a scissor as well, but I better to have that small tool that was here. It will actually cut, identically from both sides and a round shape, and you will have less chances to cut the cable. So avoid the scissors. Mostly use that, special tool. That's And when you do that, you just put a little mark here and remove that foil. And that's a special tool I was talking about. And that's how you need to cut. And yes, great. When you do that, and that's a small thread actually, fold it back. Mostly that's a thread actually to cutting more, to cut the wire into the bottom. So you use that thread. That's the important part. And fold it back. That's a polyester tab, and you need a tape, and you can actually have to put a tape here, and you can cut that too. Yeah, you cut that wire as well. And that's a secure drain wire with a copper tape. That's a copper tape. Mostly the copper tape you don't use, but nowadays actually just for the RFI and AMF thing, you need to use it. If let's say anything cut was there in the wire, so you may use it. And then trim excess wire at the back. That's a rope actually, it's a thread actually, string, that's not a wire. And that's how you untwist it. So you untwist it. Yeah, that's you make untwisted. You need to untwist. And that's how I was talking about. Remember the cable. So there is a twist cable, right? There is a twist cable, just a twist into each other. And this one, see, it twisted on each other as well through this buffer. So you have a more EMI. So you have a more EMI and EMF tolerance here. More. You will see that. Did you see that? Yes, no? Okay, let's go from further now. And you cut that buffer as well, because you cannot put in the jack if you don't cut the buffer. That's how you cut the buffer. Okay, and now when you cut the buffer, straight the pairs, you untangle these pairs. You need to untangle the pairs. So when somebody was asking me what is TIA, that was a TIA standard. That's a base TIA termination 50, I think 508 or something. That's a TIA standard. That's what you use been. So you can use it here. We'll explain the next class for sure. And that's how you remember the code as well. And you slide it actually in this. And then I'll show you the code as well. Like before that, I think I'm going to show you the code. So let me bring down the codes as well. I still use those codes through the internet actually. I remember, but I don't want to make confusion. So that's a code. So these are the codes you would see. These are the codes. Orange is, we call it stripe orange, strip orange, then white orange, or you can say, white orange and solid orange. Some people stripe orange, strip orange, white orange, and this is solid orange. Same as solid white orange, white green, green white, or striped green. Then you have a solid blue. That's how the numbers you have to keep. So first number will be this, second number will be this, third number will be this. You have to terminate in the jack. Fourth number will be this, fifth number, sixth number, 7 and 8. That's how you use it. Okay? All clear? This is just a code for the wires. So you remember, okay, how to terminate. So it has to be in the same order. Number 1, 2, 3, 4, 5, 6, 7, 8. You have to go until here. Same numbers. Okay? Clear? Yes, no? Okay, great. So you may be already done it before, so you will all clear, but everybody else clear? Chaitanya and everybody else? Okay. Okay, let me then go for the video and so that's how you will do the twisted, untwisted, and you put on the same number. So it will go to the same numbers, right? That's how they fix in the numbers. See here, you would see number 4, number 5, number 7, number 8. So let me bring that paintbrush. So that will be number 8. That's number 7. That's how you terminate. And then it's number 1. Then you number 2. I think number 2 used to be this. Number 2, number 3, number 4, right? Number 5, number 5 used to be this actually. No, let me just go again. So number 1 for sure, right? Number 2, this thing, and number 3, number 4 for voice, and number 5, number 6, number 7, number 8. That's what you use for as a termination cable number as well, TIA. That's how you actually put in the number. So you would see the numbers here as well on the jack itself as well. I used to use A. Okay. Okay, great. Yeah, and then depends on number B and E. And that's how you terminate it. Put the load bar back onto the open connector by lightening up into the arrows, right? When you connect it, see, it will go up here. It will actually align by itself. And you terminate with a special crimp. So these are special crimp tools that you get with mostly with themselves when you get so many adapters or disconnectors. So you get these tools as well. When you get these connectors, you get these tools as well. Sorry for the disruption. So you get these tools as well. You buy these connectors, most probably. Or otherwise you have to buy your own. And when you crimp it down, and that's crimped down, it will automatically cut the wire, depends on what kind of wire is that. And that's it. And close the connector, and you would have to put one zip tie as well, I think, on these kind of connectors. Yes, you put a zip tie as well on these kind of connectors, and that's how it works. All clear? Yeah, and then you just close that a little lid here. If you're not using this wire, make sure you close this door. Otherwise, there could be dust or something like that, so which will make the problem in the future. Okay, so video is end. Everybody it was easy to understand the cable termination. It was easy. Okay, great. Thank you to know that. Okay, but in the next class we will talk more about little more cable, and there's so many standards that we have to perform. Let's say what is type A, type B, then what is RJ45 cable, RJ45 type of connector, and how to terminate that. We will talk in the further class. But today's topic was Ethernet and on the Ethernet frame, and then we talk about what is the UTP shielded inside. So tomorrow's topic would be RJ45 cable termination. Okay, clear to everyone? Any confusion so far? You can come up and you can unmute yourself, like if you want to talk about a little bit, so we can end up this class and wind up thing today. Anything? Clear. Okay. All right. All right. Take care and have a very wonderful rest of the weekend ahead, guys. If you're still having weekend. And no problem, AJ. Surely we will talk again. We will clear more the concept on TIA side, and we will talk why this female and male connectors are different from the industry standards and why Cat 7 was not in the launched. But surely I'll remind that question and give you the perfect answer, which will actually help you around to crack the interviews or something in the future if there's somebody asks. But anyway, it was a very nice session with you guys. It was a pleasure to teach you, and a really nice student at least is being cooperative. Thank you. Very great. And thank you, everybody. Take care. Have a very wonderful day ahead. Bye-bye.